Our next section deals with factoring. So this is going to predominantly be, I would think, X games and slip and slide, because most of these look like they are relatively easy. We have a little bit of grouping. I also see some perfect squares down there, so we're probably going to have some difference of squares. Let's start with number one. Looks like we have a quadratic with a leading term of +1, so the X games would be a great method here. -108 in the denominator, or sorry, in the bottom of the X, -3 in the top of the X. Looks like 12 and 8 give me 12 and 9 give me 108. So we have 12 and 9, but I need a negative value, which means one of those two is going to have to be negative. I need my addition statement to end up negative, so my larger term is going to have to be negative. And those are my factors. X minus 12, X plus 9. Well, that was quick and easy. We're done with that problem. Question 11. Question 11, I have 4 terms. It's already in standard form, so all I need to do is group at this point. Since we grouped the negative sign, I want to go ahead and replace it with an addition sign. And we want to find our GCF. The GCF of 4x cubed and x squared is going to be x squared, which will leave us with a 4x plus 1. So if at all possible, I want to get negative 36x to become a positive 4x. So we're going to divide by a negative 9, which will certainly leave me with a 4x plus 1. My parentheses match, so that's one of my factor solutions, is a 4x plus 1. And the other solution comes from our terms in front, so x squared minus 9. Now the temptation is to say, we did grouping, we factored, we're done. But we always need to look back at our terms, especially when we have a squared value as a solution or as a factor, and see, is the other term in that binomial a perfect square? Well, it is. And that means if I have a subtraction sign between the two, I have a square minus a square. That's the difference of squares. Now, the difference of squares is always going to be the 2 square roots. The square root of x squared is x. The square root of 9 is 3. And it splits up into the 2 square roots, their solutions having opposite signs. So minus 3 and plus 3. And you just drop down your previous factor that you had that went with the x squared minus 9. That is 4x plus 1. And we are done with the problem. Question number 12. Question number 12, I see 3, 6, and 3. Well, all of those have a GCF. So we're going to factor out the GCF first. 3, which leaves me with an x squared plus 2x plus 1. And so within the trinomial, I have a leading term that is positive 1. So I can use my x games. We want a 2 in the numerator. We want a 1 down in the denominator, 2 numbers that multiply together to give me 1, add together to give me 2. That's going to be a 1 and a 1. So we will end up with solutions for our trinomial that are x plus 1, x plus 1. Remember that 3 was one of our factors as well, so that comes over here. $13. Well, now we're in a slightly different situation because we have a leading or an a value that is not equal to positive 1. So we're going to use our slip and slide. Multiply negative 2 times 3. It's going to give me a negative 6. We want the b value up top, so that's a negative 1. And we're trying to find 2 values that multiply together to give me negative 6, add together to give me negative 1. They're going to have to be numbers that are factors closer to each other to end up with a smaller sum. So that would probably be something like a 3 and a 2, where the 3, the larger value, needs to be negative so that we end up with a negative solution to the sum. Now, slip and slide, so let's give both of those an x because we're not done. We need to solve the rest by grouping. So 3x squared minus 3x plus 2x minus 2. And we're going to solve by grouping. So our first GCF is going to be 3x times x minus 1. And our next GCF is going to be 2, so plus 2 times x minus 1. And so again, I can see that my parentheses match, so x minus 1 was one of our factors. The values in front of them will become the other, 3x plus 2. Next question. 4x squared minus 49y squared. I have a perfect square, subtraction, a perfect square, perfect square. We've got a difference of squares, so I'm going to end up with an x, 7y, x, 7y, and these are going to have different operation signs. Difference of squares are quick and easy questions if we remember to check and realize that they are difference of squares. We're going to skip 15 because that's not quite part of this unit. Number 16. 2x to the fourth minus 32. I want to first find our GCF. So 2 is our GCF, which gives me a 2 times x to the fourth minus 16. Where we should realize, hey, I got difference of squares. X to the fourth can be split up into x squared and x squared. 16 can be split up into 4 and 4. Give them different operation signs, and we now have 2 to the times x squared minus 4 times x squared plus 4. X squared minus 4 is another perfect square. That one's going to split up. X squared minus 4 becomes x plus 2, x minus 2. That was this binomial. X squared plus 4 is not a difference of squares, rather it's a sum of squares, and we don't have any rules for simplifying that. That just is what it is. So we bring everything else and add it to our solution. And we're done. Question 17, 5x squared plus 20. We want to first factor out the GCF 5. So 5 leaves us with an x squared plus 4. And the temptation is to say, oh, difference of squares, because I've got x squared and I've got a 4. But we don't have a difference or a subtraction operation sign. So it is not a difference of squares. It is rather just a factor that cannot simplify any further.